A very good evening, everyone. So, week 9 content has been over, and we have studied a lot of stuff in that, right? So, in this particular session, in this particular live session, we are going to solve a question based on those content which we have learned, and we'll see how we can solve the assignment question. We'll not directly solve this assignment system, but we can solve the question based on which is easy, which will be very easy for us to solve the assignment question. So, let's get to it, and let me present my screen. Perfect. Let's hide this. Yeah. So, in the week 7 of the crystal symmetry and tensor, in this particular course, we have studied the following list of the topics. The topic covered are listed here: the combination of the mirror perpendicular to the plane, 2n, and fold axis. So, these are the few remaining part of the point group. So, in total, last week we did 23 of the point group completed, out of which 11 was the proper, and remaining 12 was the improper. But there was total 32. So there should be 20, overall 23 should be the, sorry, 21 should be the point group, improper point group. 12 is over, 9 was left, and 9 was covered here. So we have seen that in the combination of the mirror and plane, this produced the 3 point group further. We know they are MMM, 4 mm, 4 over M, MM, 6 mm, 6 over MM. So these three we have produced. After that, there is a mirror parallel to the roto-inversion axis. So this also produced a total of 3. And the improper cubic point group has also been discussed, and that is again producing the total of 3, making to be the total of 9, and 12 was covered previously, and that is 23, and overall 32 point group has been discussed in this particular by the end of this particular week. Then we have learned about the how we can classify them the point group to 7 crystal systems. So 32 point group has been further classified into the 7 crystal system. Then later on we studied about the chirality. So out of this 32 point group, which of the point group are there which can show the chirality to us? And those are only the proper group. The proper group can show. So that is, we know that there are the 11 proper groups. So 11 chiral, 11 point group which will show the chirality. Okay. Then we have studied about the centrosymmetric point group. How many point groups are there which are centrosymmetric in nature? Okay. And then we have learned about the Laue classes. So total, there will be overall. We have seen that there are the 11 Laue classes, and the remaining, if we combine rest of 23, other than 11, rest of 23, if we combine with the inversion, it will produce one of the this particular 11 Laue class itself. And the diffraction pattern itself is consist of the inversion center. And so we are not getting entire information of the 32 point group. Like among this 32 point group, my material is having which of the point group, that is not aware of us. Only information which we can get the out of 11 Laue classes, which class they will belong to. Then later on we have studied about the group and subgroup relations. Okay, so For example, if 6 fourfold is there, fourfold itself consists of the twofold itself within it, right? So that will be the subgroup of it. Twofold is a subgroup of the four. Later on, we studied about the polar group. How many polar groups are there? That is a 10, and they can show the dipole moment and all. Okay, then we've studied about holohedral, holosymmetric classes. That is the highest symmetry. Highest symmetry. So here, so what it is telling that we have to match the stereogram with their respective point group. Okay, so stereogram is there with us, and some point groups are written. We need to match that whether this corresponding to which of them. We have to match them accordingly, right? So let's start with the easiest one among these four. I can see this is the very less, right? It's having very less points. So let's start with this point number one, the dark one, that is above the plane. If I rotate it by 180 degree, then we can see that okay, so there, it is a twofold rotation is there, and also there will be also we can say that okay, mirror is also there, right? So let us say I'm having this particular stereograph, and I'm starting with the one of the point. I rotated it by 180 degree. I got over here, right, just opposite to this. And then if this particular thing itself is a mirror, then we can say that it will reflect back, and this is what we will get. So there is a twofold is present, we can say, and there is a mirror also there. Mirror is perpendicular mirror, it is horizontal mirror, right? So we have the twofold and we have this particular mirror. So twofold is there, and perpendicular to that folder we have the mirror. So we can see that okay, yeah, this will correspond to this particular point group. So we can say that that's how they are matched. Now let's go with another point groups, another stereograms. Start with this first one. Let us say this is our starting point. How I can generate the remaining points? If I rotate it by 180 degree, I will get this particular point. That is fine. How can I get remaining 2 points? And we have to note that this is above and this is below. So we use this particular for the above the plane. This is for the below the plane. So if I want to convert this particular point to this, what I need to do? I need to do the twofold rotation of it. So along this particular axis, a twofold rotation is must, which will convert this point number 1 to point number 3 and this point number 2 to point number 4. Along with that, we can also see that there is another mirror, sorry, another twofold. Along with this twofold, there is another twofold, additional two. So what we can see that there was a twofold which was converting point number 1 to 2, which was along this, and perpendicular to that twofold there is another one more twofold is there. So this is a combination of the two proper axes. This is the dihedral groups. So we can say that okay, yeah, there is a twofold is there, there is another twofold is there, and there is another twofold is there. So it will be 2, 2, 2. And we can match this particular with the 2, 2, 2. Now, let's move to the next one. Here we can see that if this is my starting point, point number 1, how can I get the another points? If I rotate by 180 degree, I won't get this particular point, I will get this point. Okay, so there might be possible that twofold is there. How can I get other points? What is the difference between this particular question number 1, I mean first stereogram and the second stereogram? They both are having the point at the same location, but the orientation is like this is below, this is above, this is below. But here we can see that all of them are above itself. And that can be done instead of using this twofold if we use this particular as a mirror. If you use this mirror, then this point will be reflected back to this particular point and this point will be reflected to this particular point. And we can see that there is another mirror also, we can say, which is produced. So the combination of the twofold, which produce point number 1 to point number 2, and the mirror, which is producing 2 to 4 and 1 to 3, these particular points, we can say that okay, yeah, so there is a, it's a combination of the twofold and the mirror. But what is the orientation of the mirror? Mirror is vertical, it is along the twofold. So it is along the twofold, what we can say that it is the MM2. This is what we have learned. Right? So it is a combination of the twofold and mirror. Now only one last thing is left, and which will definitely will match with this, but still let's do that. So from here, from this particular 2, how we can get to the point 3? All the points are above over here, but here we can see that additional in addition to the this particular 4 point which is above, there are the 4 point which is below also, which can only be done by the mirror, horizontal mirror, which will reflect all the points which was above to below. And with that we can see that this is a combination of the twofold plus mirror, which was the vertical mirror, plus mirror, which was the horizontal mirror. And with that we can see that this will correspond to the MMM. So now this is another question which is telling that, let me read it for you. If we add a center of inversion to the point group 2 to 2, resulting point group will be, so the question is that we have the point group 2 to 2, and if we add inversion center to it, what will we get? This is a question. Okay, so let's draw it. Let's draw 2 to 2 first, and then on that let's add the inversion center. I'm just dividing them as a reference right now. There is no mirror, there is no twofold right now. I'm just dividing them for the references. These are the reference line. So how do we draw the 2 to 2? 2 to 2 means there is a twofold with the combination of the twofold itself. Let's say this is our starting point and this is a twofold. And also there is another twofold which is over here. Now let's try to rotate them. Using this first operation of the twofold, this point will come over here. Then, if I use this particular twofold, first point will get to this over here. It will be below. Twofold will bring it down. This point will come over here. Twofold will bring it down. This is what. And also there is a twofold by default generated twofold which will bring this to this. We can see. So there is a twofold also here. But the question is that we want to add the inversion to this. This is a 2 to 2 stereographic projection. We need to add the inversion to this. So let's add this at the center. Let's add the inversion center. Let's say this is our inversion center. Then what will happen? This point, which was above, it will be reflected back in the. It will go below over here. It will be inverted over here. This point, which was below, the blue one, will be reflected over here. I should use a black color only. This red point, which was above, sorry, which is below, will be reflected back over here, and it will go below. It will go above. And this is what we will get. We just saw something like this just a few minutes back. We saw something like this cell, this itself, right? So we can say that this one is belonging to the MMM. So if we add inversion center to the point group 2 to 2, we will get MMM. So this is a question number 3. What it is telling that we have to identify the point group for the stereogram shown below. So we have the total of 3 stereogram. So this itself is having the 3 question. And what we need to do, we need to identify the point group which this particular stereogram is corresponding to. Okay, so let's try to identify them. Let us say this is my starting point. Point number 1. How can I get the another point? Another set of point. If I rotate by 90 degree, I will get this point. No. This is above and this is below. If I rotate further, I will get this. Yeah, okay, I am getting this. So yeah, twofold is there. If I rotate by 180 degree, so one operation 2 is there. How can I get another points? I don't know. Right. We don't know how we can get the another points. How about let's try some inversion also. Rotate it by 90 degree, okay, and invert it to the this particular point. If we invert from, if we follow the four bar, it is rotating by 90 degree and inverting it, we will get this particular point, and that is correct. We are getting it. Now let's follow the operation again. Rotate it by 90 degree and invert them. So we are getting this particular point. This was below and it will go above, which was which is again going right. Again rotate by 90 degree and invert them and we'll get this particular point from here to here. And so on and so forth. So we can see that it is a fourfold with the inversion. Four bar itself. And which we know that it will consist two also. From here to here and here to here. So we can see that this particular question number one, the point group is corresponding to this is 4 bar. Now let's move to the question number two. From here, let us say this is our starting point, point number one. We are rotating. Let us say we are rotating by fourfold. We got this particular point, okay. We got this point also, okay, and we got this point also after the rotation of the fourfold by 90 degree, and again we have got this. So all these points are telling that okay, yeah, fourfold is there. But how do we generate another points? This another set of point. If I want to generate point number this point from point number one, what I need to do, I need to rotate it by 90 degree, and rotation should be along this vertical axis. So this was our fourfold. Fourfold is there here, and now they are telling that if I rotate by 180 degree along this, if this is my twofold axis, from this I will get this particular point. From this point I will get this here to here and here to here. Yeah, this is satisfied. So what we can say that this is a combination of the fourfold and twofold, right? So this is a dihedral type group, that is a 4 to 2. This additional 2 is belonging to this one. These are also the two folds, right? So with that we have got this. Now let's go to this particular one, question number 3. So question number 2 has the point group of 4, 2. Now how about this question number 3? Let us say this is our starting point, right? How can I get the another point, other points? Rotate by 90 degree, you will get this. No, this is above, this is below. Rotate by 90 degree, again this is below, so you won't get. So we can see that fourfold is not there. If fourfold is not there, but let's try then 4 bar. Rotate by 90 degree, invert it, we'll get this particular point. From above it go to below, which is due to the inversion. So we got this. From here, rotate by 90 degree again and invert it. This is below, so it will go above. Yeah. So we got this particular point. Rotate by 90 degree again and invert it. We'll get this. So we got all these things, all these 4 points till now. That is a 4 bar we have got. Now, how to generate this additional points? These points, which we not generated till yet. Right. So we can say that this is a 4 bar is there. 4 bar is there, that is definitely. What else is there? From here, if I want to get to this particular point, I have to rotate by 90 degree again. Sorry, 180. This point will be rotated over here. I will get this particular point. This point will be rotated over here. From below it will go above and we'll get this particular point, and so on and so forth. So we can see that twofold is there over here. Twofold is there. Along here also there is a twofold. One more thing one can see, that over here we are having the mirror. So we can so here it is telling that 4 bar 3m point group, in this particular point group of 4 bar 3m, how many 4 plus and 4 minus operations are present? How many of them are present? This is something which we want to know. See, 3 is written at the middle. So we got to know that this will belong to cubic. Cubic crystal system. And in cubic crystal system, what we know, how many, this fourfold, 4 bar, it will be along the, let's draw it. It will be along this axis, along this axis, and also along this particular axis. So fourfold will be along this. 4 bar will be along this. We got to. So total of 3 axes are there. 3 such axes are there. 3 axes of 4 bar. And we know only 4 bar is the one which will produce 4 plus and 4 minus. 3 is not gonna produce it. Mirror is also not gonna produce it. Only 4 bar is gonna produce 4 plus and 4 minus. Right. And we know how many of such operations are there in the cube. That is, there are the total of 3. 3 axes are there. 3 axes are there. That means the 4 bar will repeat 3 times. So let's talk about the one axis only. For a time, let's talk only about the one axis. What we will get, 4 bar will give us one fold, one entire first point. Then it will give us the 4 plus, 2 and 4 minus. Let me draw it over here. 4 bar operation, okay. Oh, no need to draw also. We have seen just here. It is a 4 bar it producing the, from here we can get to this particular point by the twofold of operation. From here, how can I get to this particular point? It will be 4 Okay, so I think there is some typo over here. It was not the 4 plus, it should be 4 bar. Okay, so what we can say from here, how we can produce another points, this will be followed by 4 fold and inversion. In the clockwise manner we have rotated, so 4 plus, then we have inverted, so bar is there. Now if I rotate it by in anti-clockwise manner, 4, and then I invert it, then I will get the 4 bar minus. So we can say that so we can produce a total of these things, right? So one of the operation is producing this. Second operation will also produce this, but one is a trivial. First point is will remain as it is, right? So another remaining. So how many first 4 bar produce? Total of 1 and 2. 1 4 bar plus and 1 4 bar minus. They are produced. And how many do we have like this? We have total of 3. So one is producing 2. So how many 3 will produce total? Now in question number 5, what is been asked that which of the point group are subgroup of the point group 422? Okay, so we have the 4 2 2. This particular point group is there, and we need to find among these options which of them is a subgroup of this 422, right? So let's draw 422 first. Let me draw the reference line also. Let us say this is our starting point. What 422 means that there is a 4-fold at the center and the 2-fold with the along the axis over here. This point will rotate over here. We'll get to this. We'll get over here. Oh, I made a mistake. This would go over here. So instead of writing, let us say this is not. This is our starting point. It got over here. It got over here. Let's see if I have a white. Okay, I don't have. Uh, Better let's draw the new one. Or for a time being, if you guys can just ignore this particular one. So from this to this, we got to this particular point, and then we got over here. We'll get again over here. Considering this to be our starting point. Now we have to apply twofold onto this. right? Then it will produce hollow over here, this, this, and this. So this is what we have got, right? What about if we draw 2 to 2? Let me roughly draw it. Starting with this particular point, number 1, 2 to 2 means there is a two-fold at the center and two-fold along here also. So this two-fold will rotate point number 1 to this point over here, and then this particular two folds will rotate to this and to this. So what we can see that uh, if we talk about the 2 to 2, all the point which fourfold was having, considering the starting same point to be the same, all the points are exactly same. They are at the exact same location. So 2 to 2 is surely belonging to the is a subgroup of the 4 to 2. Now let's talk about the fourfold. Let us say this is our starting point. I rotated by 90 degree. I again rotate by 90 degree and again rotate by 90 degree. Considering this to be the fourfold. So what we can see, all the points which I have generated after the 4, this particular point group, are already present over here in 4 to 2. So we can say that the 4 is also a subgroup. 2 to 2 is also a subgroup. What about 2? If I take this particular stereogram, starting with this particular point, if I rotate it by two-fold, I will get to this point, and then again I rotate, I will get to this particular point. So this point is also present over here. Not only over here, it is also present in the 4 also, in 2 to 2 also, right? So 2 is also a subgroup of this, all these three things. So we can say 2 is also there. What about the 3 and 2? Will we get threefold? Let us say if I draw 3 2, starting with this particular point, if I rotate by 120 degree, again rotate by 120 degree, I got this. Now let's rotate about this. What we'll get this, this, and this. No, most of them are not present. They are completely different from each other. So we can say that this is not there. So the for the 4 to 2, which we are discussing about, it contained 4. Among our answers, I'm typing 2 to 2 and 2. So these are the subgroup of 4 to 2. With that, question number 5 we have solved it. One can also solve this again the same thing just by writing the symmetry operation. So then you have to write the symmetry operation of them. Nothing is gonna make difference to it. Okay. Processes will remain as it is same. You will draw the stereogram. So here is a question number 6. Let me read it for you. The question in 6 is sharing that which of the following point group belong to the cubic crystal system. So we have to find, okay, there are the multiple point groups are there to us. We have to find which of them is a cubic crystal system, which will correspond to the cubic. Okay, so what do we know about the cubic crystal system? That the defining symmetry for this is a 4 threefold axis. So we can say that okay, a threefold is will be there. So we will remove all the point group which is not having three for a time being. Let us say okay. So first one is not having threefold. It got eliminated. B is having threefold. Let's keep it. C is also having threefold. Let's keep it. Six. We can remove this D. There is no threefold over here. E, we can see that yeah, there is a three bar is there, which is three only. Three two. Okay, yeah, three is there for a timing. Let's keep it. G is also three is there. H is also there is a three, and I there is no three. Okay, there is no threefold. So we directly in our first go we remove all the things which were not having the threefold in them. Now we know that this trigonal system is also having the three, right? And our cubic is also having the three. But what is the difference? It is only having the one threefold. But in the symmetry point of view, how should we remove that? How should we eliminate this? Separate this? Let me give a very easy trick to solve this. In this threefold, for the cubic system, that 3 will always be present in middle. That is, there is a three position. Point group is specified mostly by the three positions most of the time. Okay. If it is not specified the three position, it means that okay, another last one is a one trivial symmetry. So the middle position, let us say M 3 bar M. We know that this is a cubic. So at the middle position of the point group, 3 will be mentioned. If anywhere other than this second position, if anywhere other than the second position is 3 is written, then that doesn't belong to the cubic crystal system. They will belong to some other crystal system. So now, considering this thing, let's eliminate the remaining part. We can see that okay, a 3 is there at the second position. Okay, so we are keeping the B. C 3 is there at the first position itself. We are eliminating this. 3 is there at the second position. Okay, yeah, we are keeping it. First position, eliminate it. Second position, we are keeping it. And we also know that this is belonging to dihedral group. This is not the cubic group. 3 is coming first. So what this consists of the that there is a threefold and then there is a twofold also there. And this is a trigonal crystal system. This will correspond to the trigonal crystal system. 2 3 is written, 3 is there at the second position. This is belonging to the cubic crystal system. So we are keeping G. H, yeah, 3 is there at the second position. We know it will belong to the cubic, so we are keeping this also. So with that, we got to know that okay, yeah, B, E, G, and H they belong to the cubic crystal system, and this is how we have eliminated the point group. Okay, so with that, our this question number 6 has been solved. You can cross verify them these things checking in the lecture, and it will work very fine. Okay, especially if I tell you that this second position second position of the point group will correspond to the 111 direction itself. So this the wind direction of this is 1. Here is our question number 7. Let's read it. Let me read it for you. Identify crystal having which identify crystal having which of the following point group stereogram will show the dipole moment. Okay, the language is not very clear. So they are saying that among this, we have to write, first of all, we have to write the point group of this particular stereogram, and then we need to find out whether they will show the dipole moment or not. Okay, so what we have learned in our class that which one we will show the dipole moment. There was a specific group, 10 group was there which was showing the dipole moment. It was one, two-fold, three-fold, four-fold, and six-fold. Right. Then there was a mirror, mm2, 3m, 4 and 6 So we are removing all vertical mirrors, and with that we of course got that okay, these are the point group which will show the dipole moment. In another point groups, the dipole moment will be cancelled out and effectively we will get zero. Only these particular point groups are having the invariant axis, rotation axis. Okay, and along that particular rotation axis, we will get the dipole moment effectively. There won't be net. There won't be zero. Okay, so now we need to find the point group corresponding to these things. If you are following this, we have already done this part of finding the point groups over here. This 4 is corresponding to this. Okay, so let me just write down as it is, whatever it is written. So what we have already found out that 2, 2, 2. This one is 2 over m. No, sorry. This one is mm2. This one is 2 over m, and this one is mm. We found that in the question number 1 itself. Okay, we have marked all of them. Now, what about this below? This is also we have done it. Let me show it. I think it was question number 4, I think. Oh no, it's question number 3. So here we can see that this first one is 4 bar. This is 422 and 4 bar m2. Right. So now what we need to do, we need to find that okay, which of them will show the dipole moment to us. And we already know that okay, these 10 are the one which are going to show. So this consists of the mm2 is there, 2 over m is not, this is not there, 2 over m is not there, and mm is also not there, 4 bar is not there, 422 is not there, and 4 bar m2 is also not there. So only one of them we have got that it will show the dipole moment. And with that we have solved this question number 7 itself. No, chiral question based on the chirality. So we need to find, the question is telling that which of the following figure, there are the four figures, one, two, three, and four. Which of the following figures are the chiral? If something is chiral, it means that they shouldn't have inversion, sorry, any type 2 operation we can say. If type 2 operation is not there, then it is a chiral. Okay, let's start with the first one. Is there any type 2 operation? Let's think and then answer it. So what we can see that if I rotate this by 90 degree, it will come over here. It will coincide just with this below one, right? And if I invert them, then it will come over here. So it is having the roto-inversion. About this point, if we invert, if I rotate it by 90 degree, and if I invert it, then we will get something like this. Okay, so this is a 4 bar axis. And so since it is a type 2 operation, we can say that it is not a chiral. Our hand, does it having any type 2 operation? Mirror? No, mirror is not there. It is, there is a inversion. No, inversion is also not there. So our hand is a, does it's not having any type 2 operation. So no type 2 operation. It means that, yeah, second one is a chiral one. So first we have eliminated. What about third one? We have studied a lot about this in our 10 plus 2. So whether this is chiral or not, that is something which we need to find. In another way, we have to find whether it is having any type 2 operation, that is a mirror, inversion, or rotation. Sorry, not rotation. Mirror inversion or roto-inversion. So if I say this is our my center, I am not able to find fluorine over here. Backward, I am not finding any fluorine. So it is not having any inversion. It is not having the mirror also. Okay, all the four elements, all these four of them are different from each other. So there is a no type 2 operation. So we can say that, yeah, this is a chiral. What about the question number 4? If we see it properly, what we can see, there are the two hydrogen are there. So considering this to be our mirror plane consisting of the fluorine and chlorine, if I consider this to be the mirror plane which contain both fluorine and chlorine, so what we can see that hydrogen can reflect with each other, that is a mirror is present. And since mirror is present, which is a type 2 operation, so since type 2 operation is present, we will say that it is a non-chiral. Okay, so here it is, that holosymmetric group of the hexagonal pressure system. Holosymmetric, that is the highest highest symmetry, highest symmetry point group. That too, we need to find out the hexagonal system. Right. See, there are the multiple way. One we ca- One is that, yeah, okay, we already know that in the class it has been done. We can go with that particular videos and all. Another way is that more symmetry elements, higher symmetry point group will have the highest symmetry. Since it is having the highest symmetry, if we take any general position, it will produce more number of points. So their stereogram will have the highest number of points. There is a one of the thumb rule we can say that we can follow it, and if you do so, you will get this particular point is having the highest one. It will be having, I think, 26 fold is there. Then there is a mirror, and then there is another mirror. So there will be 24 total of 24 will be there. And with that we can, and this is the highest symmetry for our hexagonal crystal system. For triclinic it is a 1, and for monoclinic it is a 2 over m, and for trigonal we have 3 over 3m, 3 bar m, and orthorhombic we have mmm, and then for the this tetragonal, yeah, for the tetragonal we have 4 over mm. For hexagonal we have 6 over m, and then there is a cubic which is having the m 3 bar m. So these are the highest symmetry group corresponding to their 7 crystal systems: 1, 2, 3, 4, 5, 6, 7. Okay, it is very easy to remember. See, most of them triclinic we have already know, and remaining most of them are they are having this MMM type, that is a n-fold of rotation with the mirror perpendicular and parallel also. But just remaining things we have to learn it. Again, see over here also that 3 is at the middle. This is corresponding to the cubic, and 3 is at the first position. This is corresponding to the trigonal. Okay, so with that we have solved all the questions of this particular week, and I assume that, yeah, with that we can solve all the assignment question. Okay, if there is any difficulty while solving the assignments question, please you can always let me know. You can comment on the you can post your question on the doubt forum. You can comment on this particular lecture which is going on. We'll definitely respond to it. Okay, so with that, we have solved all the questions which was aimed for us to solve this time. And with that, we can end our today's session. Thank you very much, everyone, and let's meet in the next upcoming sessions.